Hey guys, so this is the reaction that is in my PowerPoint that I just did a presentation on, and I'm going to go through with you how to assign oxidation numbers to all of the different compounds. And I know that this is a little bit harder because there are multiple elements now in some of the compounds, so we're going to take our time and go through it together. Okay, so let's start with the easy ones. The easy one that I noticed first is this copper. Copper here doesn't have a charge on it. So as is, all elements on the periodic table are neutral. It shows that it's neutral because there's no charge on it. So I'm just going to go ahead and assign copper's oxidation state of 0. And that actually goes the same with silver on the product side because there's no charge on it. And again, it's not bonded to anything else. And all elements, as is on the periodic table, as I just said, are neutral. So it is also neutral. Both of the compounds that we're going to work on now, silver nitrate, this guy, and copper nitrate, this guy, they're both also 0 because there's no charge up here. But you have different elements bonded together, so the elements will have an oxidation state in the compound. So let's go through and assign oxidation numbers. So because I know it's 0, I'm going to set the whole thing equal to 0. And I know oxygen is -2, as it always is. And there are 3 of them, because there's a little 3 right here. So I'm going to write it 3 times. Now, I also know that nitrate, if we go to the periodic table, nitrate, NO3, is a polyatomic ion. So if you go up to the polyatomic ions, here we are, and let me just rotate. Nitrate is right here, and it has a negative charge, as you can see from the little minus that is right next to it. So the whole ion, NO3, has a -1 charge. So if we go back, while the whole compound is neutral, this part of it, NO3, is going to have a -1 charge, which means that silver has to have a +1 charge. Let me just grab my pen. So this whole thing is -1 altogether. So this, the only way to make this 0 is for this guy to be +1. And if you look at the periodic table again, silver over here has a +1 oxidation state. And you might have just asked, well, Ms. West, like, why didn't we just, go there first and say, oh, silver has a +1 oxidation state, instead of making it complicated and finding out nitrate overall has a -1 oxidation state. And my response to you would be that, remember from the start I said group 1 elements are always +1, group 2 are always +2, oxygen's always -2, and fluorine's always -1. Everyone else can have different oxidation states. So while silver likes +1, who knows? Maybe there's another one it might have. So we just wanted to reaffirm that that was in fact its oxidation state. So we just did, and there's no harm in doing that. So silver, we know, is going to be +1. Now, we don't know what the charge of nitrogen is, so I'm just going to put plus, ooh, that's a bad plus x. And we have to solve for x. So I'm going to just rewrite this to make it a little prettier. We have x +1 minus 2, 3 2's make 6, minus 6 equals 0. And so that is ultimately x minus 5 equals 0. And same as before, we do the opposite sign to move this guy over to the other side. So x is just plus 5. So we solved for the oxidation states of all of the elements. We solved for silver, which is plus 1. Oxygen, each one is minus 2. And nitrogen is plus 5. You could even go back in and like triple check and be like, okay, well, plus 1 plus 5 gets you plus 6, and 3 negative 2's get you negative 6, and you add them all together, you get 0 overall. And the way you could double, triple check it is to be like, well, I knew that my NO3 by itself would give you negative 1 charge, and if I have nitrogen being plus 5 and 3 negative 2's, that plus 5 and negative 6 equals negative 1. So NO3 is in fact negative 1. So we know we did that one correctly. Okay, well, let's now try the hunk of the one, copper nitrate, which is a little bit harder, but not too bad. So now we have multiple nitrates. We have 2 nitrates. This 2 gets multiplied onto the oxygen and onto the nitrogen, everything in the parentheses. Again, this is a neutral compound, so I'm going to set the whole thing equal to 0. I know oxygen is going to be the state that it usually is, which is negative 2. So I'm going to write negative 2. But how many times do you think I should write negative 2? Well, if you multiplied this little 2 onto that 3, you would get 6. So there are 6 oxygens in the overall compound. So I'm going to write negative 2 6 times. 2, 3. Whoa, that's not what I wanted. Yeah. I can't, like, speak and write, apparently, at the same time. Negative 2, negative 2, negative 2. Okay. So that takes care of our oxygens. Now, we are in a precarious situation because we don't know copper's oxidation state and we don't know nitrogen's. If we go to the periodic table, we will see that we have copper is right here. Copper can be plus 1 and plus 2, and who knows, maybe there's even more oxidation states it can be that we don't know about. So we have to do the same situation that we did before, where we know that each nitrate, each NO3, is negative 1 charge. So I'm going to just say right on the bottom, I'll change colors and make it red. Each NO3, you know what, I'll put it right here. Sorry. Just scaring myself. Each NO3 is minus 1, and there's 2 NO3s. Now, if the overall compound is neutral, copper therefore must have overall a plus 2 charge. That's the only way plus 2 and 2 negative 1s equals 0. So we know copper's charge over here is plus 2. So now we just have to figure out nitrogen's charge. So we're going to say plus x and give ourselves some space. So overall, simplifying this, I have x plus 2 minus, let's see, 1, 2, 3, 4, 5, 6. 6 times 2 is 12, minus 12 equals 0. So I have x minus 10 equals 0. And then following the opposite sign, I add 10 to both sides. So x equals positive 10. But I made a mistake, and the mistake I made is a very important mistake to understand, so I'm not going to restart this video. And the mistake that I made is that I never multiplied the 2 over here onto the nitrogen. So there's really 2 x's here. What? Because that 2 gets multiplied. So that only changes our bottom math here. And so I am going to just make a small adjustment of saying we have the whole same problem, except there are two x's. Plus 2 minus 12 equals 0. Instead, I have 2x minus 10 equals 0. Still add 10 to both sides. And here I have 2x equals positive 10. So now I divide both sides by 2. Because 2 is being multiplied by x here, that's why I divided. So x really equals plus 5. And so don't make the same mistake I made, and make sure you multiply that little subscript that's outside of the parentheses onto both of these guys. It does not get multiplied onto the copper because the copper is not in the parentheses. So, those of you who are wondering, no, it does not, this little 2 guy, my mistake of the x's did not, I still did the top part correctly. There are 2 nitrates overall. So it's minus 1 and minus 1 on top, and plus 2 from copper. So the top part I did correctly. And now I know I did the bottom part correctly because each nitrogen is plus 5. So let's go back and check our math. So I have plus 2, and I'm going to make this a little cleaner here. So I have plus 2, plus 5, plus 5. So that gets, and there was a 2 here that I erased. So that gets us plus 12 overall, and then this is minus 12. So plus 12 cancels out minus 12 to get us 0. So we know we did it correctly. So copper is plus 2, nitrogen is plus 5, and oxygen, as per usual, minus 2. So I have now solved for all of the oxidation states on all of the compounds.